Okay, we're here at gotomath.com. Click on the calculus. Bet you thought this was going to be a silent video. We're here at the finding the area between curves. And let's take a look at, we got 1.1. Let's click on that. Right, so we had a section called area where we worked with only one function, finding the area underneath one function. And so now we're going to throw in two functions. Okay, as you can see here, f of x and g of x, which I pretty much use throughout. Alright, so we want to find, it says find the area of the shaded region in the interval between 0 and 4. So the way these increments count, this is 0, 1, 2, 3, 4. Now of course we don't need to use calculus to figure out what the area of this is, right? We can just do this geometrically. 1, 2, 3, 4, 1, let's see, 1, 2, 3, 4, and length times width is 4 times 4 is 16. So our answer should be 16. However, we're going to use calculus to go ahead and set this up and start on something easy. So our answer should be 16, right? Alright, well, let's write these two functions down. f of x equal to 1, g of x is equal to 5. Alright, between 0 and 4. Okay, so let's head over to the whiteboard, and I'll go ahead and write these up here again. So f of x, if you didn't get that, is equal to 1, and our other was g of x is equal to 5. Okay, and we were on the interval between 0 and 4. Alright. Okay, so I have to roughly sketch this over here. And we're trying to find, let's say, this area right here. Okay, we shall say, in fact, let's just color it green. Okay, so the way this works is we take the integral of 0 of 4 of this function, which happens to be our g of x. Okay, what happens is, let's just do that. I'll just do it generally right here. Going from 0 to 4, this area, which we'll call area 1, is actually the area all the way from the top of the function down to the x-axis. So this is what we would be finding. We would be finding all of this area. Alright, we'd be finding all of this area. And then what we'd want to do is go from 0 to 4 of f of x dx. And what happens here is we end up finding the area from here, from this function. See, this is our f of x here, finding this area. Alright, and so what we'd end up doing is taking the larger area and subtracting off the smaller area to get this area right here, which we'll just call area A. So to find area A, the green shaded region, you would take the top function, which is this guy right here, area 1, and subtract off area 2 to get this area here. Alright, so that's basically what we're going to be doing throughout, is take the top line, subtract it from the bottom line, right, to get the in-between stuff. Okay, so the way we'll set this up is we're going from 0 to 4. Alright, and actually I'll write it out like this. So the top line, which is 5 dx, so that would be this guy right here. No, sorry, this one, looking at the wrong one. Then subtract off 0 to 4 of the bottom line, which is 1 dx, right? Normally we wouldn't write 1 dx, okay? But since both of our boundaries are the same, our functions are different, but our boundaries are the same, our upper and lower limits for both of these, we can combine this into one single integrand, and so that ends up becoming 5 minus 1, right? This would be our g of x minus our f of x and dx, and that's the way we're going to want to do that, okay? So let's go ahead and simplify this down. Now what's really interesting about this is graph that, right? When you graph this guy right here, you get a totally different graph, which I think is pretty cool. And that is just a constant, but it passes through 4. It passes through 4, and now what we're doing is we're finding the area under here. And it turns out that this area is equal to this area here, all right? Okay, well, you should know how to take the integral of this, right? So this is just 4x going from 0 to 4. We use the fundamental theorem of calculus, right, to do this. So 4 times, let's see, let's just write it out here. 4 and then minus and then plugging 0 in, right? And so we end up with 16. Now, because we're finding area, technically, you know, if we were using some kind of units, it would be units squared, like centimeters squared, feet squared, whatever our area is squared, okay? But we're not going to be writing that in, all right? Okay, so that should be a fairly decent explanation on what's going on here. Okay, so there's 16, and remember, we could just look at that and go, oh yeah, that's 16. But when this guy, this is not changing, this is constant, but when this starts changing, right, we're going to have a hard time trying to figure that out. Okay, so let's go up here, let's hit the answer and make sure the script is all good. It says 16, good to go. Alright, come on by, go to math.com, practice. I got a ton of problems here. See you later.